Hey everybody, this is Alex Merced, and welcome to another video about data topics. I was just like browsing some of these Slack channels for some of the data lakehouse table formats, and I saw a conversation about being like, when is it better to do bucket partitioning versus sort partitioning? And the answer is depends. Okay, like anything in data depends on the data you are working with and sort of the kind of queries you're trying to optimize for. So I figured I'd break it down a little bit. And again, always recommend that you subscribe to the YouTube channel, which you can find right over here, youtube.com/AlexMerced Data. Okay, so subscribe, leave a like on the video, leave a comment, all that good stuff. But first, we need to establish sort of like, again, what is partitioning? Okay, so let's imagine that I have a data set. So let me create a little table over here, just to get as a, okay. Okay, so let's just pretend like this is a data set about teams. So basically we have, okay, we have teams, or actually we have an ID number, the name of the person, the team that they are on, and the state that they're from. Okay, so we have IDs 1, 2, and 3. We got Bob, Steve, and Susie. Okay, and we have red, blue, red. Okay, and we have Texas, Massachusetts, North Carolina. Okay, so there's our table in a sense. Okay, imagine that's like hundreds of thousands of records. So now partitioning just basically means that when you write the data, particularly when you're talking about a data lakehouse table format, so this is like the Apache Iceberg of the world, where the data gets written to Parquet files. Okay, that data is going to get written when you partition the data set. It means the data that fits in a particular partition will get written to unique files. So, for example, if I were to partition based on team, okay, so then what would happen is all the all the people in the red team would be partitioned to a separate set of Parquet files than the people in the blue team. Okay, so that's partitioning based on a particular sort of raw value. This is great when the cardinality of um, the cardinality of the column is low, which just means there aren't many unique values. Okay, so in this case, there's red team and there's blue team. Okay, and even if there's like maybe 2 or 3 more other values, that'd be fine. You only have a few partitions. Okay, so that and this would make sense if the searches are typically based on team members. So if I'm typically looking, hey, can you give me all the red team members? Can you give me all the blue team members? Then it makes sense to partition on that field because that's what people are searching for. So that's the query pattern piece. And it would make sense to partition it based on the value, okay, then because that's the value that people are searching for. But now let's say people are typically searching basically based on state, okay? Well, there are 50 states in the United States, okay, and plus some territories. So now here's the deal. Okay, that would be a lot of partitions. That may be fine. 50 partitions may be fine. It may not be. Depends on, again, the size of your data. But in that case, maybe you don't want that many partitions. Okay, maybe because some of the states just don't have as much data as the others, and you get what's called skew, where based on partitions are just much larger than others. So in this case, you rather spread the data across a smaller number of partitions. Okay, but still break it up somehow. This is where you do bucketing. Okay, so in bucketing, what you would do is that you would establish a function that will hash a value into a fixed number of buckets. So let's say I want to take these 50 states and I want to bucket them into 10 buckets. Okay, so that means generally each bucket's going to end up holding about data for about 5 states. I don't care which states, I just want to break it up this way. So essentially what happens is in a bucketing partition, you'll have a hash function that will hash the value tx, ma, and c into one of those 10 buckets. So the Parquet files, like when they get written, anything that hashes into bucket 1, so any state that any of the 5 states that hash into bucket 1 will be written to those files. And again, the reason why you want it written to different files is because a query engine, when they scan a data lakehouse table using a format like Apache Iceberg, the metadata will help them identify which files have the relevant data. So if the data is partitioned by, let's say, again, going back by team, I say I search for, hey, give me all the red team members. Okay, the data that it has on partitioning, it'll be able to just basically automatically just clear out all the files that have blue team members and say, hey, I don't need to look at those. And you just avoid the scanning of those, which makes your scan a lot faster, saves you money, all that good stuff. Now, if I'm doing scanning by state and I do a bucket, okay, based on the way it's partitioned, it will be able to eliminate the other 9 buckets, and then I'll only have the bucket with the states that are relevant to me, okay, for my particular query, and then I can go scan those files, okay? Um, so that's essentially the difference. So again, the difference would be cardinality, okay? If it's a high cardinality column, meaning there's a lot of individual values, okay, which means, okay, there's just a lot of different possible values, then bucketing makes a lot of sense because you don't want so many different partitions. Because you might run into the possibility of partition skew, again, where some partitions are bigger than others, which means queries that hit those larger partitions are going to be slower than the ones that hit the smaller partitions. So that's the deal when you would want to use which. And again, it depends on what people are searching. If people aren't searching by state, then I'm not worried about the cardinality of the state column. So I wouldn't be partitioning using a bucket strategy on the state column. I'd be using maybe just a normal, just the value partitioning on this column. But when it comes to creating your data files, also with your tables, you can generally specify what's called a sort order. So when it writes those files, it can sort them based on a field. Okay, so in that case, if I am doing a bucket strategy with state, and I sort everything into 10 buckets, I may still want to sort those files based on state. So that way, even within the bucket, so let's say one bucket has Texas, Connecticut, Massachusetts, California, and Washington, that's one bucket. If I sort those by state, chances are all the Connecticut records will still be in the same sort of batch of 3 or 4 files. All the Texas data will be in the same batch of 3 or 4 files. That using things like the Apache Iceberg metadata or the same metadata for other table formats, you'd still be able to narrow down even within that partition to a smaller subset of files for an even faster query. So there's the partition, sort of the high level, how do we write the data into separate files? And then there's the sorting of data within those files, which using the metadata can still allow you to get even more granular with how you prune those files. Okay, a really optimized table should be partitioned based on values that are typically queried. Okay, you can use the value of the column, use just partition based on the value if it's a low cardinality column. Consider using things like bucket or truncate. In Apache Iceberg, you have also the ability to partition based on a truncated value. Use those for like higher cardinality columns to kind of reduce that cardinality. So you can use truncate to, let's say, hey, I want to partition based on the first letter of someone's name. So then you can truncate it to one value, and then you end up with 26 partitions depending on the first letter of that person's name. Okay, as an example. But again, what are my query patterns? Partition based on the types of columns that we query based on. Okay, and then still sort those files. And especially if you're using a bucket, make sure to still sort within there, so that way at least you have neatly clustered files inside each partition. Okay, so hopefully this gives you a better idea. Again, there's no sort of set rule on how you do this. It just depends on sort of, again, what is your data, and what are the needs of your data. And that's always the best place to start. Be like, okay, what are people going to be asking my data? And then let me structure with that. And that's why it's nice about something like a Apache Iceberg, because Apache Iceberg allows you to kind of figure that out with time. Okay, generally, oftentimes you may partition your table one way and realize you need to partition your table another way later on. With most table formats and most places, you end up having to recreate the table to rewrite all the data files to match those changes. Apache Iceberg allows you to do this incrementally. You can change your partitioning scheme and only apply it to new data being written, and then you can rewrite the old data when it seems appropriate or never. Okay, and it'll still be able to search the table for any query. Okay, so which makes Apache Iceberg really cool. And again, one of the best ways to get started with Apache Iceberg is using the Dremio Lakehouse platform. If you haven't gone to youtube.com/Dremio to see the videos I have there about using the Dremio Lakehouse platform with Apache Iceberg, I highly recommend checking those out. But either way, if you enjoyed this video, make sure to like, subscribe, and I'll see you all later.